In a factory in Wuhan, engineers trying to build the world's most advanced memory chips discovered they couldn't order the machine that makes that possible. The equipment was blocked, the export license denied. The elevator, to borrow a word they would never use publicly, was padlocked shut. What happened next is not a story about China catching up. It's a story about a company that had no choice but to find the stairs and discovered, once it got there, that it had accidentally built the only staircase in the building. The restriction was meant to cap the ambitions of Yangtze Memory Technologies Corporation, the Chinese memory manufacturer that had been climbing toward the world's most advanced flash storage. Cut off from the top tier of lithography equipment and blocked from importing the most precise deposition tools by controls enforced through the United States Commerce Department's entity list, the company should, by the logic of the policy, have stalled. Layer counts frozen. Roadmap capped. Instead, Yangtze Memory filed more hybrid bonding patents than Samsung and SK Hynix combined. Not approximately, more. The word for what it did is workaround, and that word is going to mean something different to you in about 10 minutes than it does right now. This is how a ceiling became a ceiling joist, and why Samsung should be paying close attention to a competitor it still outsizes by almost every traditional measure. Conventional NAND flash memory scales by stacking layers vertically, each one deposited and etched with precision that depends on lithographic equipment of the highest order. More layers mean more storage density per chip. More layers also mean more passes through the machines Yangtze Memory could no longer freely import. Think of lithography as the elevator in a skyscraper. Every competitor uses the elevator to add floors. Yangtze Memory's elevator got padlocked, so it looked for the stairs and found something faster. The company pushed its NAND layer count from 160 layers to somewhere between 232 and 270 layers, depending on the product line and which trade reports you trust, because the company has not published a full public breakdown of the exact architecture. The technique it used is called hybrid bonding. Two separately fabricated stacks of memory joined face to face at the copper level, with connection points finer than a strand of human hair, no solder bumps required. Conventional stacking is like building a skyscraper floor by floor from the foundation up, limited entirely by how precisely your crane can place each beam. Hybrid bonding is like fabricating two halves of the building in separate factories and welding them at the midpoint. The weld is the hard part, but you have just halved your crane problem, and the crane is the thing you cannot import. Here's where I want to be clear about something, because the framing of workaround understates what actually happened. Hybrid bonding is not architecturally inferior to single-stack lithographic deposition. For certain stacking problems, it is better. The bonding interface allows each substack to be optimized independently before joining, which means defects in one half don't propagate the way they do in a monolithic stack built layer by layer. Yangtze Memory didn't settle for second best. It arrived at what may be first best via a forced shortcut. That distinction matters enormously because it changes the question from how far behind is it to on which dimension is it actually ahead. The patent ledger is where that dimension becomes concrete. Reports citing patent database analysis put Yangtze Memory's hybrid bonding patent holdings at roughly 119, compared to approximately 83 for Samsung and around 11 for SK Hynix. Lay them end to end. Yangtze Memory's stack is taller than both competitors combined. Those figures should be treated as estimates because patent counts shift as filings publish, and because the exact scope of what counts as a hybrid bonding patent varies by how you define the search. But the directional claim holds across the methodologies that have been publicly reported. The company barred from the front door has written the deed on the back entrance. I want to be honest about what that means and what it doesn't. Patent counts are not manufacturing prowess. Holding 119 patents is not the same as holding 119 patents that will survive litigation, or that cover the specific implementations Samsung and Micron and SK Hynix will actually ship. Semiconductor patent portfolios are notoriously crowded, cross-licensed, and contested. Yangtze Memory's leverage depends entirely on whether its claims are narrow enough to be specific and broad enough to be unavoidable. Those are two conditions that rarely coexist neatly. But here's the thing. This is a standard-setting moment. The industry has not yet converged on a single bonding architecture for the next generation of memory. In that window, owning the intellectual terrain is leverage of a different kind than owning a manufacturing lead. Samsung's 83 patents don't make it a follower. They make this a race. Yangtze Memory is currently leading on one very specific scoreboard, in a moment when that scoreboard is being designed. The deeper strategic reframe is this. Export controls are built on a theory. Block the inputs, freeze the output. The theory works when there is only one viable path to the output. When there are two paths, blocking one may redirect all of a company's engineers and capital and problem-solving energy toward the other. Samsung's roadmap, like most incumbents, was built on lithographic scaling. That is the path that requires the equipment Yangtze Memory cannot buy. The company was pushed off that highway. It built the bypass. Now every manufacturer moving toward hybrid bonding as the next dominant stacking method may eventually encounter Yangtze Memory's patent portfolio. The toll concession on the bypass was written by the company that had no choice but to build it. Before anyone declares a victory lap, the three strongest arguments against this reading deserve to be stated plainly. First, no independent benchmark has confirmed that Yangtze Memory's highest layer count products perform at the level the architecture implies. Yield, endurance, read and write latency at production scale. None of that is publicly disclosed. Layer count is a structural metric. It is not a performance guarantee. Second, patent holdings and patent enforceability are not the same thing. A crowded portfolio is only as powerful as the claims that hold up when tested. Third, and most importantly, hybrid bonding solves a stacking problem, not a logic density problem. Yangtze Memory still cannot access the leading process nodes needed for the peripheral circuits that control NAND arrays. Samsung and SK Hynix can. That gap, which the export controls help maintain, limits how fast Yangtze Memory's controllers and interface logic can advance regardless of how elegantly it stacks the memory cells. Weighed together, the win is real, documented, and specific. The victory lap should be proportionate to a specific win, not a total one. And yet the specific win is the one that rewrites the next decade, not the last one. My honest read is that the export controls did what they were designed to do. They kept Yangtze Memory off the leading-edge lithographic path. What the architects of that policy may not have modeled is that the leading-edge lithographic path was a road with a ceiling. Hybrid bonding may not have that ceiling, or at least not the same one. Yangtze Memory was pushed off the highway and found the mountain pass. It's slower going in some ways, and the summit is not fully in view, but it's also the only route the map hadn't labeled yet, and Yangtze Memory drew the map. The wall didn't stop them, it became the map, and the map led somewhere no one else had bothered to survey. Yangtze Memory is not Samsung. It cannot buy what Samsung can buy or build what Samsung can build. Not yet, not fully. But it now holds the workaround that everyone else needs, and it holds it precisely because the front door was locked. Workaround. That word opened this video meaning inferior substitute. It ends it meaning the technique the industry is standardizing on, owned by the company that had no other choice. The most dangerous kind of innovation isn't the kind that comes from abundance. It's the kind that comes from being told no. If Yangtze Memory's hybrid bonding patents hold up under scrutiny, what does Samsung do next? Challenge them in court, cross-license, or build entirely around them? Tell me what you think happens over the next 5 years, and why. And if you want the version of this story that doesn't flatten the nuance, subscribe. That's the only kind we make here.